Hi, welcome to KubeCon. This is the Multicloud Vitess over Network Service Mesh joint talk between Network Service Mesh and Vitess. I'm Tim Swanson, Senior Tech Lead from Emerging Technologies and Innovation at Cisco.
And I'm John Watson, a Site Reliability Engineer for the PlanetScale DB at PlanetScale.
So today we're going to go through the integration of Vitess with Network Service Mesh and Virtual Layer 3 deployment. So we're going to start off by highlighting the pertinent use cases for why you would want to integrate with these two projects. And then we're going to describe Vitess's architecture so we can understand what components are involved when we do this deployment. And then we're going to talk about how some of the details for Network Service Mesh Virtual Layer 3 interdomain and how it works and some of the benefits. And then we'll go into the integration between the Vitess deployment on a enabled system or a multi-cloud system with NSM interdomain. And we'll do a demonstration.
Vitess's core philosophy is to facilitate the scaling of applications by managing the complexity of scaling databases with little to no interference with application development. For example, Vitess multi-cloud can be used to effortlessly provide a homogeneous interface to your database in any cloud provider, thus preventing vendor lock-in while increasing the availability and durability of the database too. Vitess provides durability by replicating shards across cells, and for replication to work, Vitess needs to be able to securely communicate across availability zones, regions, and/or cloud providers. Another Vitess multi-cloud use case is able to comply with data location regulations without re-architecting your application. Vitess sharding will handle routing data and traffic to the appropriate jurisdiction with little to no changes to your application. Vitess is already built with availability in mind by replicating shards across failure domains. Vitess multi-cloud takes this concept and applies it to whole cloud providers. In Vitess, a failure domain is mapped to a cell. Each cell usually contains a set of tablets, VT gates, and application servers. With multiple cells, the local VT gate will handle routing traffic to the designated shards in the appropriate cell, and the tablets will handle replicating the shard data across cells. Vitess multi-cloud is cells across cloud providers instead of just regions or availability zones. Vitess relies on the networking provided by the infrastructure it's deployed on. In the case of Kubernetes, that's the CNI of the cloud provider and its pod. For multi-cloud networking, we need to securely connect multiple connectivity bands together. Unfortunately, applying an organization's networking and security requirements usually entails toil, since it requires using cloud-specific APIs and per Kubernetes cluster network policies to allow access to only specific workloads.
Okay, as John was saying in the last section about the takeaways for implications of multi-cloud networking, the toil that's involved in clouds provider-specific network connectivity between other clouds and being managed in bespoke ways is just is something that we're trying to get away from, and we're trying to create that's a kind of a goal of the Network Service Mesh interdomain project. And NSM with Virtual Layer 3 is built to kind of alleviate a lot of those use cases those toil in those use cases for application administrators. So this brings up what is NSM really. So NSM, in a nutshell, is managing connections between clients and client workloads and network services that are provided by one or more network service endpoints. And network service endpoints are the abstraction in the NSM world for different types of network functions. So as a network function provider, you can implement a network service endpoint and have a administrator provide that as a network service to any of the client workloads in their domain, their NSM deployment. So how does this work? So NSM handles requests from clients. So there's a network service request API that gets handled by the network service manager, and the client initiates that, and the network service manager, to handle that, it uses it consults a network service registry to find any endpoints that are registered for that type of network service, and it decides which network service endpoint that it got back from the registry to connect the client to, and then it forwards the request to the network service endpoint that it chose, and then it negotiates the connection parameters and does the actual connection setup to the client. So that's the gist of the NSM model for managing connections. So you applied to a Kubernetes environment, which we refer to as a single Kubernetes environment is what we refer to as a domain in NSM. And a domain is the NSM Kubernetes domain has a network service manager on each node, so it's able to coordinate connectivity between nodes, between clients on one node and endpoints on other nodes. So the same basic flow as the previous slide, but it's triggered by NSM has an admission controller that pays attention to annotations on pods or deployments, and that causes a init container to be added to that client's deployment, and that is what is doing the actual request initiation to the network service mesh control plane. And the network service mesh control plane does the actual lookup of the NSEs for that network service, chooses which NSE, and then forwards the request to the NS manager that's local to that NSE. And that NS manager will then forward the request to the actual NSE. So there's kind of layers of connection parameters being also exchanged here. The clients are saying what type of connection that they would be able to handle, and the NS managers are indicating what kind of connections that can go between the nodes, and like a VXLAN tunnel, or in the actual NS manager on the node to the NSE is also negotiating their side of the connection. So there's a lot of connection parameter exchange in this flow, and that provides a lot of power. You can see there's no centralization here. It's just the central component is the network service registry, and that is really just pointing at available network service endpoints. So when we go interdomain, you can see how this model extends, because the same idea can be used to carry out the connection across domain boundaries or cluster boundaries. The detail of how that connection between the nodes in different clusters is the difference of this environment versus the single cluster. But on a node level, the control plane flow is the same, and then between clusters, the control plane flow is basically the same, but the parameters in that connection message are and there are possibly are intermediaries to help get the control plane message to the actual other network service manager in the other cluster. But all that logically is just essentially like proxying the same message to to the right destination, and then the exchange of the actual parameters required for the layers of the connections to enable the connection between the actual client in one cluster to the network service endpoint in another cluster. That's all figured out in the context of that control plane message exchange. So it looks exactly the same from a flow point of view, and the details of that connection pipe are going to be different, but at the setup logical view, it's the same. And the other takeaway here is the network service registry and interdomain has to be able to know which endpoints are a part of the interdomain environment. And I'm showing one block as the network service registry, but that also could be a distributed kind of registry as well. So in the virtual layer 3, what we're doing is we're implementing a specific type of NSE, and that NSE is functioning as a layer 3 gateway router. So it's from the point of view of the client workload pods, and it's connecting to the peer NSEs. So the other VL3 NSEs in the interdomain environment, it's connecting to those via NSM. So it's using NSM to find the other peers, and it's using the network service registry for that purposes, and then using NSM interdomain connection setup to connect to its peers and exchange L3 route information and IPAM information. So the model is pretty in this picture. We're trying to show the same flow, but with the L3 NSE as the specific how it specifically works. So in the case of the VL3 NSE, we have a annotation, the same model where we apply an annotation for a network service. That annotation corresponds to the actual connectivity domain network service of the network service. So in this case, it's the connectivity domain called green, and that NSE that it's connecting to has a mapping of that is configured to connect to the network service registry for that connectivity domain. So that network service registry knows about the other NSEs in the connectivity domain. And when that happens, when that connection happens from the client, the NSE will find the other NSEs that are in that connectivity domain and trigger connection requests to form the actual peering between the other NSEs. So and cause the NSM implementation to create the data plane connectivity between those NSEs across the cloud boundaries or cluster boundaries. So when another client comes up in the cluster 2, in this case, in the flow that we just described, that actual connectivity domain is already up, and all that is happening is that client is just getting connected to the NSE, and then it is now a part of the L3 network that makes up that connectivity domain. So the client in cluster 1 can reach the client in cluster 2, and vice versa, as if they were in the same cluster, or just via the same layer, just a single layer 3 network. things pods outside of this that are in those clusters that are not part of this connectivity domain cannot reach things across the cluster boundary because they are not enabled. They're not connected to the NSE. So connectivity domains are a totally an opt-in approach to joining to multi-cloud connectivity. Only the workloads that are a part of the connectivity domain are a part of that. So there's no need for extra intercluster network policy. So this is now we're going to transition into how Vitess and NSM are integrated with the virtual layer 3 NSEs. So like in the previous slide with the example for the NSEs, we have now a Vitess deployment that's in the connectivity domain that is between multiple clusters. And the Vitess deployment has multiple pods, and there's multiple reasons for those pods to be able to communicate with the other clusters, instances of different pods. So all of those in the deployment are all the content in these Vitess deployments are a part of the connectivity domain. And then the connectivity domain also has some additional services like DNS that is DNS only for the workloads that are connected in that connectivity domain. So there's a DNS representation for the service workload for the workloads that are in that connectivity domain. So this is a kind of a breakout of which pods are deployed where. In this example, the PlanetScale operator deploys VT-Gate, VT-Tablet in both clusters, but at etcd in a single cluster. And the VT-Gates can reach either any VT-Tablet, so that kind of fulfills your data location use case, so since you can localize shards or tables according to your regulations, location regulations. And then the VT tablets can reach each other across the connectivity domain, and that would solve your data replication, multi-site data replication use cases. So both of these use cases are solved just by this single type of deployment. Okay, so we're going to do an actual demo where we show what deployment like what the previous slide showed. So the details of this demo are a 2 Kubernetes cluster setup with NSM installed, the NSE control services that I showed in the previous slide for DNS and IPAM, and the registry are in a 3rd cluster. So they're not going to be shown, but they're there. And then the actual demo flow, we're going to set up the virtual layer 3 network service endpoints in each cluster, and that's going to be a script that does that, so it's going to be hard to follow, but the gist is that it installs the NSEs and it has them registered as network service named Vitess, and they're configured to be a part of the connectivity domain with the same name. So they're going to be configured to point back at those NSE services that are in the control, the other 3rd cluster.
Then we're going to deploy Vitess pods to both clusters as virtual L3 NS clients. We're going to be using the Vitess operator for Kubernetes to handle the Vitess deployment, because it not only automates the deployment of Vitess, it will automate the management of Vitess on Kubernetes as well. Then we will use Vitess to create a database table and shard config that will illustrate the connectivity domains, and then we'll show the shards are split between the clusters via separate Vitess cells, and then we will show replication across these clusters by using a a planned failover as a way of illustrating that there's inter-cluster network provided through the virtual L3 connectivity domain. So now here we are with the demo, and we are going to have an installer cluster in Europe, cluster in the Americas. In each of those are going to be not only a Vitess cell, but a cluster in NSM. And then we'll start off with installing the virtual L3 NSEs in both clusters. This will take a few seconds, and then wall of text, but no, it comes through. And there we go. We now have NSE running in both clusters. And next up, we are going to install Vitess in the Americas region. This will be our primary region, so we are going to put our topology servers running on etcd in the Americas regions. We are using the Vitess Kubernetes operator to handle all of this. We just feed it a cluster configuration in Vitess, and the operator then handles bringing up each of the etcds, the tablets, and the control plane as well, and then follow that up with the VT gates, which provide the connectivity to not only this local cluster, this local cell, it will also provide connectivity to the other cell. Here we go with Europe. We told the operator to apply the NSM connectivity domain annotation to all pods in the Vitess cluster. And since the operator is also managing the tablets with just a couple lines of code, it extends the annotation so NSM registers a service for each tablet so they can communicate across the clouds using the NSM connectivity domain. And then now that all tablets are ready, that means they are connected and it has now chosen a master and the replicas are connected. And each region has both things. And we can see the NSM network services are now configured with the virtual L3s. And here's our endpoints, as well as the annotation that shows us attaching the deployment to the connectivity domain. And same thing in the Europe cluster, with the same network service endpoints, as well as the annotations that tells the injects the sidecar into our pods. Here's our Vitess control panel. We have two shards in the user database, -40, where we have the Americas has the master and a replica in Europe, as well as a second shard of everything greater than 40 is only in Europe, because we will map all all non-Americas users into the European cluster. Here is our table, and we will have a full name, national ID, and country. We will use country as our way of routing our users. We tell Vitess to use a v-index based on the country that is provided by the user. We have a static mapping in a JSON file that just says country name of a country to a sharding key, and that sharding key then applies to the key space of being less than 40 or greater than 40. Here you can see the same two shards in the -40 key space, and here's the European equivalent, showing that they're only in Europe. And the control panel also gives us the same detail and shows us that each tablet, where each tablet is and which one is the current master. We are now going to watch the query logs of each of the tablets so that we can see how Vitess is routing the queries locally and across the connectivity domain. So now we're going to start a MySQL client that is not attached to the connectivity domain, and it will not allow us to use the special NSE that we created for the VT gate. However, since we did not disable the local Kubernetes service definition, there is still the Kubernetes service cluster service that is created for the VT gates for local services to connect to. And that is still available to use. However, if we do start a MySQL client within the connectivity domain, then it will be able to use the connectivity domain service name to connect. And we'll be able to disable the VT gate service, Kubernetes service entirely, so that only connectivity domain pods can be there. So now we're inserting some data, making one into the US and one with a French national. And you'll see that it only went, the US citizen went to the Americas master, the French citizen went to the European master. We'll now do a select query. You can see we were able to get the data from both sides, from both masters in both different regions. Then we can instruct the VT gate to only direct queries to a single cell. In this case, we're saying we're going to query only the Americas shard. So now we only see the US citizen reinserted. And then we can do the same thing with the European shard. And now we can only see the French citizen. So now we are going to do a failover of the America's master into the European region. Say if you wanted to do some maintenance in the Americas region, we can now do a plan reparent, which is a plan failover that your application would not notice at all because the VT gate will pause the query while this reparent occurs. So now we can see that the master is now in the European cell, and the Americas is now a replica. And while still connected to the Americas VT gate, we can see that it routed the query to the European replica through the connectivity domain. And then we can still perform normal scatter-gather queries. In this case, now both replica shards are entirely in the European cell. We'll now fail back to the Americas cell for the American shard. And we can show that we are now failed back over. We can insert more data to show that the insert now goes to the Americas shard. And we'll do another scatter-gather to show that the data we inserted while the European shard was master is there, as well as the last insert of the Canadian citizen after we failed back to the Americas.
So that's our talk. For the references, the NSM, there's some links here for the NSM project and the virtual layer 3 NSE that we've worked on at Cisco, and the Vitess project and their PlanetScale operator that you saw live in the demo. That was what was orchestrating the whole Vitess installation. This is the the Vitess schedule. Some of these have happened, but they're interesting talks that you may want to check out recordings of. And similarly, the NSM Con was a day zero event that had a couple of talks that would be directly useful if you're interested in NSM interdomain and virtual layer 3. And the keynote was on the previous slide. We've discussed it a little bit, and then there's a talk coming up on Thursday that's going to have a lot more of the latest and greatest details for the network service mesh project. Thank you, and this is our contact information, and have a great conference. Thanks.
Thank you, everybody.